So now we are on to 4.5, and what 4.5 is all about. It's negative and reciprocal exponents. Now, with this section, we're adding an additional rule to our toolbox. So after this, what am I going to be able to do? If we focus on here, we can see this general expression. So x to the power of negative n, so we have a negative exponent. What happens is you can actually take the reciprocal. Okay, what is a reciprocal? Now, down here, we can kind of see what a reciprocal is. Essentially, what a reciprocal is, if x and y are reciprocals of each other, they can multiply and form positive 1. So here we can see 5 equals 5 over 1. So the reciprocal of 5 would be 1 over 5, because when you multiply those two numbers, you get 1. Here, 3 over 4, its reciprocal would be 4 over 3. Because when we multiply 3 over 4 times 4 over 3, well, that gives me 1. So to find the reciprocal, all you have to do is just flip the fraction. That's literally it. So negative 1 over 7, its reciprocal is negative 7 over 1. We can see when we multiply that, you get 1. And it even works for variables. X equals x over 1. Well, the reciprocal of x over 1 is just 1 over x. And when we multiply these two reciprocals, you get 1. Okay, so when you have a negative exponent, you can just take the reciprocal. And this even goes a little further. Say we have a over b, and the whole thing is to the power of negative n. Well, this, we can just flip the insides to b over a, and that makes your exponent positive. Okay, so if we have, for instance, 4 over 3 to the power of negative 2, we can make that exponent positive by flipping our fraction and taking the reciprocal, and that makes us get positive 2 as an exponent there. Say, as we can see, 4 over negative 2, we just take the reciprocal and our exponent becomes positive 2. Here we have 1 over 2 to the power of negative 3. It works the other way as well. We can put that on top and you get a positive exponent. So, up to this point, we have the following tools. We've went over all of these exponent rules up to 4.4. Actually, this is 4.5, up to 4.5. 4.5 is all about adding this new rule here. So, we kind of just talked about this. We must learn what negative exponents means. So negative exponents can be made positive by taking the reciprocal. Okay, so again, a reciprocal of a number is some number that multiplies, or that multiples a number to equal 1. So that should be multiply there, actually. So if, for instance, x times 1 equals 1, that means x and y are reciprocals. So that's kind of described down here. Okay, and a reciprocal is something that you would have learned in grade 9. Okay, so here's a kind of an overview of negative exponents. Okay, so then there's a few examples down here. So we have 3 to the negative 2, we flip, so we get 1 over 3 to the power of 2. Here we have a power of negative 6, and we have a fraction inside, so if we flip that fraction, we get a positive exponent. Okay, so let's apply the reciprocal rule to gain a positive exponent. So here, 4 to the power of negative 3, well, I'm going to put that on the denominator's position, and it'll be 1 to the power of 4 over 3. Or sorry, 1 over 4 to the power of 3. Let's look at b. So we have 1 over 5 to the power of negative 8. If I take the reciprocal and make it to the positive 8, you therefore get a positive exponent. Okay, so we're going to really ramp it up. We're going to start introducing variables. It's really important to remember variables, so things like x, y, z, so on and so forth, these are literally just numbers we don't know yet. So with numbers that we don't know yet, they still apply the same rules. We just represent them as x, y, and z. So here, this variable x has a negative exponent. So what I'm going to do is I'm going to put that on the bottom, and it'll be x to the power of 5. Okay, so you can see I now have made a positive exponent. Here, y to the power of negative 2, well, I can put that on the bottom of my fraction and get power of 2. 4 here, this is really important. 4 is not being applied to -2, okay? Only z is. So that's where your brackets are really important. For z to the power of -2, absolutely, this is being affected by that power. But 4 to the power of z, 4 times z to the power of -2, only your z is being affected by it. So since only my z is being affected by this -2, I will therefore put it on the top. So what happens to my number? Well, my number doesn't have a negative exponent on it. It's simply just 4, so it just stays right where it is. And there we have simplified with variables. Okay, actually, sorry, that should be, I don't know what the heck happened there. That should have been my z to the power of -2 becoming z to the power of +2. Okay, and there is my solution. As we can see, all of my exponents are now positive. Okay, so let's add this to our toolbox. So we can now add this to our exponent toolbox. So now we have all of these rules to be working with. And again, does it feel like a ton? Absolutely. But up to this point, you should have been doing practice problems where you're getting really, really used to all of these ones before. So these ones should be kind of something that you've dealt with. Here, your negative exponents, now we are dealing with a new thing. So if you have x to the power of -n, you can take the reciprocal, put that number on the bottom, and you get a positive power. Here, if you have a denominator with a negative exponent, then you can put it on top and get a positive power. And then here, if you have a fraction on the inside being applied to a negative exponent, you can actually flip that fraction. So b goes on top, a goes in the denominator, and now you have a positive exponent. So let's move forward here and practice a few more things. So express the following expressions with positive exponents. So here, this will become 1 over 4 squared, and you know what a 1 over 4 squared is, that is 1 over 16. So this thing equals 1 over 16. You could plug that into your calculator and see what it is. So let's check it out. So here, I could try 4 to the power of -2, and remember your power button is here. And then I could do 1 over 16, and it gives me the same answers because, again, they're the same value, they're just represented differently. Okay. Let's go to our next example. Now we are going to be talking about, 5 to the power of 4 times x over 2 to the power of -3. Now, recognize that this doesn't have an exponent, but anytime something doesn't have an exponent, you can imagine a little 1 as their exponent. Okay, so here, in order to get positive exponents, the only one I really have to worry about is 2 to the power of -3. So what I'm going to do is I'm just going to bring that on top. So it'll be 5 to the power of 4 times x times 2 to the power of +3. Now from here, remember, multiplication is commutative. It's kind of like saying 4 times 5 is the same thing as 5 times 4. So we can just manipulate and move these variables around and these numbers around and multiply in any order we want. So I'm going to represent with numbers first, because that's usually the way we like to perceive things. So 5 to the power of 4 times 2 to the power of 3 times x. And then from there, we can find the solution. So 5 to the power of 4, that's kind of tricky to know. So I'm actually just going to plug this into my calculator. So this would be 5 to the power of 4. And remember, your power button is over here. Bracket 2 to the power of 3 bracket. And that becomes 5,000. Now, can we really do anything with this x variable? No, there's no other x variable to manipulate it. So realistically, nothing's going to happen to that x variable, so it just follows along. So it'll be 5,000x. So let's plug this into our calculator and see what we get. So 5 to the power of 4 brackets, and I'm going to divide by 2 to the power of -3, because I just simply want to see what happens here. Well, of course, it's going to give us the same solution, right? Because all we have done is just reorganized and use an exponent law to express this in a different manner. Okay? So let's move on to a next topic here, or next question, sorry. So here we have brackets 4 over 9 to the power of negative 3 over 2. Well, here I'm going to utilize my rule up here, okay? So I have a negative exponent on a fraction, so I'm going to flip my fraction. I'm going to take the reciprocal and make it 9 over 4, and that's going to make 3 over 2. Now, we understand how to utilize this because remember, we're going to use a few different rules. We're going to use the fact up here that when we have exponents, okay, fractional exponents, our denominator will be the index and my numerator will be the power. So here, this will become square root 9 over 4, and this whole thing is cubed. Okay, and remember that 2, if we don't write a 2 here, we just imagine a 2 being there. Okay, we don't have to write 2 because when we don't write it, we just assume it's 2. And from here, remember, we can either cube everything first or we can square root everything. So what I'm going to do is I'm then going to use my other rule here. So when things are being square rooted, well, I'm going to break that apart and it'll become square root A over square root B. So here, this will become square root 9 cubed over square root 4 cubed. And then from there, I can either cube 9 first or square root it. I'm of course going to square root it because that's easier. That will become 3 to the power of 3 over the square root of 4, which is 2, and that will be cubed. And then from here, 3 cubed is 27 over 2 cubed is 8. And there is our solution to this. So this thing equals 27 over 8. And again, we could check our answer there. How could we check our answer? Well, we could take our calculator and we could use brackets 4 over 9 to the power of negative 3 dividing 2, and make sure you're utilizing brackets. So again, this might take a bit of practice in how to plug that into your calculator. If things just won't work, please come see me or email. Okay, so we get 3.375. So let's plug in 27 over 8. And again, of course, we get the same answers because these are the same solutions. They're representing the same numbers, just in a different way. Remember, this is wearing different pants here. It's the same expression, just in a different format. Okay, let's go on to how to work with variables. Remember, and this goes back up top here, variables are just numbers. We don't know yet. So don't overanalyze the fact that there's letters now, these variables. They still have the same applications as numbers. So here, my 5, I can't do much with. It's going to stay on the top because it has a positive 1 as its exponent. My x has a power of negative 3, so I'm going to bring that into the denominator's position and represent it as x to the power of 3. Z squared, well, that has a positive power, so it's going to stay on top. And then y to the power of negative 5, well, I may as well bring that to the top, and I go get y to the power of 5. And there's my solution there. Okay, I cannot simplify that any further. So let's move on to maybe a few more. And here again, I've just listed all of those rules so you can keep referencing these rules as we do these problems. Okay, so determine the simplest form of each expression. So we're going for the simplest form. So what's the smallest expression that we can get to? So here, my first step is I want that negative exponent out of there. So I'm going to put 27 on the bottom, and that will be to the power of positive 2 over 3. Okay, now here, my numerator of my fraction is 2, and my denominator is 3, which will be my index. So I'm now going to apply my rule here. Okay, so this will become the cube root of 27. And remember, I can square that either after or before. I'm going to put the square after cube rooting this because cube rooting this is easier. The cube root of 27 is 3, and that will be squared. So this will be 1 over 9. And there is my solution. That's 1 over 9. Let's move on to this other example here. So I have 1 over 4 to the power of negative 4 over 2. So again, I have a negative value here. So as soon as I have a negative exponent, let's get that turning into positive by taking the reciprocal. So this will be 4 to the power of positive 4 over 2. Now I can simplify this. 4 dividing 2, well, that simply equals 2. And now I'm left with 4 squared, which will be 16. So this equals 16. And again, let's utilize our calculator to check my answer. Okay, so brackets 1 dividing 4, bracket, to the power of, bracket, negative 4 over 2, brackets. And that will give me 16. Okay, so we can see that we can utilize our calculator to check my answer. Recognize if I ever told you to show all of your work, okay, and you cannot use a calculator, you have to do it this way. Okay, you have to show me how to solve it algebraically. And trust me, learning how to do this early on in high school or in grade 10, whatever you're at in life, this will help you moving forward in more difficult courses. Okay, let's move down here. So we have 1 over 81 to the power of negative 0.5. Okay, the first thing I do is I really want to get rid of that negative exponent. So this is going to be 81 to the power of 0.5. Now 0.5, we should know that that's 1 over 2, right? That's a half. So I can represent this using a fraction. So this is 81 to the power of 1 over 2. And now I'm going to use my rule of where if I have a fractional exponent with an index, with a denominator of n, that's actually my index. So here, this will be the square root of 81. And I can actually represent that without even writing the index, because remember, when you don't write the index, you imagine a 2 being there. And hopefully we all know that the square root of 81 is 9. So there's my answer for this. Let's move on to the very last one here. So we have negative 125 to the power of negative 1 over 3. So again, I have a negative exponent. So let us get that to become a positive. So I'm going to put this all on the denominator's position, and that will create a positive exponent. Recognize my negative still stays with my number. It's not the number that changes signs, it's your exponent that changes signs. Here, I'm also going to apply the fact that my denominator is 3. If my denominator is 3, that means I can make my index 3. So this is actually asking, what is the cube root of negative 125? And we've done that quite a few times in previous videos. And by hopefully this point, you remember that negative 5 cubed will equal negative 125. Remember, you can only root a negative number if your index is an odd number. So this will be 1 over negative 5. So that equals negative 1 over 5. And again, can you check it in your calculator? You absolutely can. Okay, so let's see and let's check. So negative 125 to the power of negative 1 over 3. So it's negative 0.2, and if we plug in negative 1 over 5, it's the same number. So this also equals negative 0.2, okay, in decimal form. So we're going to test out and see if we can apply our knowledge to maybe more of a word type problem. So something you might see in kind of your everyday life, whether you go into engineering or mathematics or business or whatever you might see. This is something that will be important to everybody once they reach an age where they might be investing some money. Okay, so here Mr. Skaber wants to have $5,000 in 8 years. He uses the below formula to calculate how much he should invest today in a savings account that pays 7.5% compounded annually. So here's our equation, and P is how much he should invest. How much I should invest. And we want to figure out how much I should invest today. So we're going to take this, P equals $5,000 times 1.075 to the power of negative 8. So here's an equation that we can solve for P. Now we can use our knowledge of powers and exponents. So recognize there's brackets here. So that means this 8, negative 8, is only affecting this number. 5,000 is not being affected. So I'm going to make that into a positive exponent by putting it on the bottom. So there, now I have a positive 8. So here I can plug this into my calculator. So 5,000 dividing 1.075 to the power of positive 8. And it looks like I should invest $2,851 into a bank account, because in 5 years it could grow up to 5,000, which is actually a good amount of money to pretty much not doing anything other than going to the bank and opening an account. So if I put this much money into a savings account, I will end up actually making $5,000 if that interest rate stays the same, which hopefully it will. Okay, so please go and check your understanding with AFL 4.5. Again, understanding this stuff, especially moving forward in either the -1 or the -2 stream, is going to be really critical, okay? So make sure you do lots of practice problems, because there's lots of different types of questions that can be asked. So yeah, have a good day.